Hello, so today I'm doing my recording on chapter 15. Um, this is about host mechanisms and their defenses against viral properties. Okay, so this is the defense mechanisms of the host. So we have adaptive immunities. The host defends itself against microorganisms, and it does that in various ways. So the body has a system of barriers. Um, which we'll talk about later, but your body has many different systems to help flush out and kill these bacteria. But when it detects an invading a foreign substance, it will send help, and it emits chemicals to help fight off these um, substances. So it has three lines of defense against invading microorganisms. So the first line blocks anything at the portal of entry. Um, this would be like your skin and your mucous membranes. So your second line is your protective cells and um, fluid. Your second line would include inflammation and phagocytosis, and it also involves the local and systemic. The third line would be foreign substances that are encountered by your white blood cells and eventually killed. Okay, so there are many different host defenses. So we must have a healthy, functioning immune system to be able to kill these invading bacteria. So humans have many forms of host defenses that overlap, making it hard for any foreign invader to survive. So you have many different systems that interlap and allow these bacteria to be killed. Um, so antigens, they play a role in surveillance of the body and recognition of foreign material. They also destruct enemies that are foreign. Uh, so self, this is your microbes that display a unique sense to determine if they are foreign. Um, so the white blood cell determines if they are of the body. Your non-self, this would be your invading bacterial cells. And your body detects both of those. Okay, so the first system that plays a crucial role in host defenses is your lymphatic system. So they have many different roles. They transport lymph. It includes lymph fluid and your primary and secondary lymph organs. So first off, we have they transport the lymph um, through many capillaries and vessels. Um, so then you have your lymph fluid, and this carries white blood cells around the body. Um, So this is like the route of return of extracellular fluid to the circulatory system, drain-off system for inflammation and surveillance of foreign materials. So you have your primary lymph organs. This is your red bone marrow and the thymus. So the primary lymph organs is immune cells that where they are born and they grow. Your secondary lymph organs is your lymph nodes and spleen. This is where the immune cells eventually carry out their functions. Okay, so another important system would be your blood. So the lymphatic system correlates with this system. They kind of overlap. So you have your whole blood, and this consists of your red blood cells in your plasma. Hematopoiesis, this is the production of blood cells, and differentiation, this is hormones that cause cells to change over time. So your blood rapidly circulates throughout your body, and it also helps to carry these white blood cells to the body and flush out things from the body. So it plays a very, very important role, not only to oxygenate your body, but destroy invading microorganisms. So you have your mononuclear phagocyte system. This is another body system that helps fight microorganisms. So the function, tissues of the body are connected by reticulum, and reticulum that connects cells. So phagocytic cells in this network make it its name, which is a thymus, which they are primarily found in the thymus. And in the thymus, this is where the white blood cells mature. So again, your first line of defense. This is your skin and mucous membranes. It's a very tough layer, and few pathogens can penetrate it. One way that pathogens can enter through the skin would be cuts and tears in the skin. So you never want to have dry skin because it promotes cuts and tears. So keratin, this is a protective and waterproofing protein that is found all over the skin mucous membranes. So sweat glands help remove and flush out those microbes, which I thought was pretty cool. So your respiratory tract. So one way the body rids itself of invading pathogens is through coughing and sneezing. Another way would be through the eyes. If you cry, it'd be tears, or if your eyes start watering, it flushes out those pathogens. So through the digestive tract, when you eat food, you are consuming pathogens. So when that food enters the digestive tract, it turns acidic, which they usually cannot survive in the very acidic environment that our stomach houses. So your second line of defense. So phagocytosis. This is a process which destroys any foreign invader. So it recognizes and surveys the system. And three main types of microorganisms that destroy invading microorganisms would be your neutrophils, monocytes, and macrophages. So through a respiratory burst is it contains several destructive aspects. Myeloperoxidase and hydrogen peroxide. Inflammation. There are several events of inflammation. So inflammation is a response to any traumatic response to tissues. So there are many signs that the body carries out for inflammation. So you have redness at the site, warmth, and swelling is three indicative indications of inflammation. So early events would be vasculature, chemical mediators, and vasodilation. And later events would be like edema. So this is leakage of vascular fluid into the tissues. And then later events would be your fever. And I'll get into that in a minute. Okay, so a fever. So this is an abnormally elevated body temperature. Scientists have studied fever and have discovered that it has a positive um, aspect on destroying microorganisms. Usually, when people start running a low-grade fever, it's a good sign and we let it run its course, but um, if it gets too high, medication might be involved to help reduce that temperature. So fever can be associated with not only a virus, but cancer and allergies. So it's normally regulated by the hypothalamus. Pyrogens reset the hypothalamus to a higher temperature when the body starts to have a fever. The normal range for fever, or normal temperature, body temperature, is 98.6. But if it elevates into a low-grade fever, that would be like 99 to 101, kind of is the range for a low-grade fever. And then high-grade would be on up, and so on. So musculature increases heat production when the body discovers it has a fever. So pyrogens are also an aspect of the fever. So exogenous would be outside of the body. This would be viruses and invading microorganisms. Endogenous would be released inside of the body. So this would be your macrophages, monocytes, etc. So endogenous is good, exogenous is usually bad. So, stated before, there are many benefits of a fever. So, it inhibits multiplication, impedes nutrition of bacteria, and it also increases metabolism. So, scientists have been discovering the positive aspects of a fever because usually when somebody says they're running a fever, it's like a negative connotation. But in reality, a fever is just part of the body system trying to rid itself of the microorganisms and let nature playing its course. So, like I said before, if the fever gets too out of hand, usually medication is involved to reduce that fever. But if the body is running a low-grade fever, it's just a normal inflammation response trying to rid itself of the microorganisms. Um, so usually, and I thought about this example too. So if you get a cat scratch, there's such a thing called a cat scratch fever. And when you get that scratch, there'll be inflammation at the site of the scratch. You'll have redness and swelling, and eventually that infection can get systemic and your body will start running a fever. And usually medication is involved to stop that. It's a very serious infection. So, like I said before, there are many treatments of a fever, and we will get into that now in later slides. So interferons, they are produced in response to a virus. Their activities are extensive. So one of their main functions is to bind to cell surfaces, and they also change the genetic disposition. So they are small protein produced by white blood cells. It's kind of hard to see, but they play a major role in the body's defense systems. So antimicrobial peptides, they have the ability to insert into bacterial membranes and they eventually kill the microbes. So these are very important aspects as well to help the body invade itself and rid itself of microbial invaders. So host restriction factors, these are mechanisms that limit the ability to replicate inside of the host cell. So they bind to certain parts of the virus and they prevent assembly of a new virus.